Space Shuttle Challenger STS-51L. On January 28, 1986, the Space Shuttle Challenger lifted off from Kennedy Space Center at 11:38 in the morning, carrying 7 crew members and roughly 17 million school children watching live in classrooms across the United States. The teacher was Krista McAuliffe, a 37-year-old social studies instructor from Concord, New Hampshire, who had been selected from more than 11,000 applicants to become the first civilian in space as part of NASA's Teacher in Space project. She was seated next to Gregory Jarvis, a payload specialist from Hughes Aircraft, who had been bumped from 2 previous shuttle missions to accommodate politicians and now finally had a seat. Behind them were mission specialists Ellison Onizuka, a Hawaiian-born Air Force test pilot, Judith Resnick, an electrical engineer and classical pianist who had been the second American woman in space, and Ronald McNair, a physicist and black belt in karate who had grown up in a segregated town in South Carolina, and as a child had refused to leave a public library that told him it did not serve black patrons. In the flight deck above them were Commander Dick Scobie and pilot Michael Smith, a Navy aviator who had only been assigned to the mission weeks before launch. 73 seconds after liftoff at an altitude of 46,000 feet above the Atlantic Ocean, the vehicle was torn apart by aerodynamic forces following the catastrophic failure of its right solid rocket booster. All 7 crew members were killed. McAuliffe had planned to teach 2 lessons from orbit broadcast live to schools across the country titled The Ultimate Field Trip and Where We've Been, Where We're Going, Why. Neither lesson was ever taught. What had been a moment of national celebration broadcast live to an audience larger than any shuttle launch before it became one of the most watched tragedies in American television history in a matter of seconds. The cause of the failure had been documented, argued over, and formally escalated the night before the launch. Engineers at Morton Thiokol, the contractor responsible for manufacturing the solid rocket boosters, had spent the evening before the launch in a teleconference with NASA management, raising a specific technical objection. The rubber O-ring seals that prevented hot combustion gas from escaping through the joints between booster segments had been observed to lose their resilience in cold temperatures. The overnight temperature at Kennedy Space Center had dropped to 29 degrees Fahrenheit, the coldest conditions any shuttle had ever faced at launch. Roger Boyes-Joly, a Thiokol engineer who had been raising O-ring concerns in written memos for months, explicitly recommended against launching below 53 degrees Fahrenheit, the lowest temperature at which the booster had previously been tested. His colleague Arnie Thompson drew charts on paper during the call, trying to illustrate the relationship between temperature and O-ring damage. The chart showed a clear pattern. Every flight that had experienced the worst O-ring erosion had launched at lower temperatures. Thompson later said he slid the charts across the table toward NASA managers, and they pushed them back without looking at them. NASA launch managers, under pressure from a schedule that had already been delayed 5 times on STS-51L alone, pushed back. They told Thiokol management that they needed to take off their engineering hats and put on their management hats. Thiokol management overruled their own engineers. The launch was approved. During the teleconference, Boisjoli later said he had the feeling that he was about to watch his own funeral. At T+58 seconds, black smoke was visible on launch footage near the joint between the lower segments of the right solid rocket booster. By T+72 seconds, a plume of flame had breached the joint and was burning directly against the strut connecting the booster to the external liquid hydrogen tank. The strut failed. The tank ruptured. The liquid hydrogen and liquid oxygen propellants mixed and ignited in a fireball that consumed the external tank and separated the solid rocket boosters, which continued flying on independent erratic paths until range safety officers sent destruct commands. The orbiter itself was not destroyed in an explosion. In the conventional sense, it was torn apart by aerodynamic forces when the structural integrity of the vehicle was suddenly lost at a speed of Mach 1.92. The crew compartment separated intact and continued on a ballistic arc, reaching an altitude of approximately 65,000 feet, before beginning its fall into the ocean 2 minutes and 45 seconds later. Investigators examining the recovered wreckage found that at least 3 of the crew's personal egress air packs had been manually activated after the breakup, confirming that some members of the crew had survived the initial structural failure and remained conscious long enough to attempt to respond. The crew compartment hit the water at an estimated 207 miles per hour. The impact was non-survivable. NASA did not publicly confirm that the crew had survived the initial breakup for several years after the accident. The finding that personal air packs had been manually activated was not released until 1986. Investigators completed their analysis of the recovered hardware, and the full crew compartment accident report was kept internal until 1988, when it was released following pressure from the crew families. The families had been told the crew died instantly. They were not told this was uncertain. The Rogers Commission, convened by President Reagan and chaired by former Secretary of State William Rogers, published its findings 5 months later. It concluded that the technical cause of the disaster was the failure of the O-ring, which was itself a consequence of a design flaw in the joint that had been known to NASA and Thiokol since at least 1977. But the commission went further than identifying a mechanical failure. It described in language that was unusually direct for a government report an organizational culture at NASA in which safety concerns raised by engineers were systematically filtered out before reaching decision makers, and in which the pressure to maintain launch schedules had created an environment where the absence of a catastrophic outcome in previous flights with O-ring damage was being treated as evidence that the damage was acceptable, rather than evidence that the program had been getting progressively lucky. Richard Feynman, the Nobel Prize-winning physicist who served on the commission, conducted his own parallel investigation and famously demonstrated the O-ring's temperature sensitivity at a press conference by dropping a piece of the material into a cup of ice water and showing that it had lost its elasticity at 32 degrees Fahrenheit. In his personal appendix to the commission report, which NASA initially attempted to prevent from being published, and which was only included after Feynman threatened to remove his name from the report entirely. If it was omitted, Feynman wrote that NASA management had been performing a kind of roulette with crew safety, and that for a successful technology, reality must take precedence over public relations, for nature cannot be fooled. The shuttle program was grounded for 32 months. Boisjoli was later awarded the Prize for Scientific Freedom and Responsibility by the American Association for the Advancement of Science, an honor that recognized the personal and professional cost of the testimony he gave against his own employer. He was effectively marginalized at Thiokol after the investigation reassigned to a role without meaningful duties. He left the company within a year. A replacement orbiter Endeavour was constructed to take Challenger's place in the fleet. Space Shuttle Columbia, STS-107. On January 16, 2003, Space Shuttle Columbia lifted off from Kennedy Space Center on what was designated as a dedicated science mission, carrying 7 crew members: Commander Rick Husband, a deeply religious Air Force colonel who had piloted the first shuttle docking with the International Space Station, pilot William McCool, a Navy commander making his first space flight, mission specialists Michael Anderson, David Brown, Kalpana Chula, and Laurel Clark, and payload specialist Ilan Ramon, a colonel in the Israeli Air Force, a veteran of the 1981 Israeli strike on Iraq's nuclear reactor at Osirak, and the first Israeli astronaut to fly in space. Ramon had brought with him a miniature Torah scroll that had survived the Bergen-Belsen concentration camp during the Holocaust, a decision he described as symbolizing hope and continuity. At 81.9 seconds after liftoff, a briefcase-sized piece of foam insulation broke away from the bipod ramp of the external fuel tank and struck the leading edge of Columbia's left wing at approximately 530 miles per hour, punching a hole through the reinforced carbon-carbon panels that protected the wing structure from the heat of re-entry. The impact was captured on launch cameras. The crew was not informed. They spent 16 days in orbit, conducting 80 separate scientific experiments across disciplines including fluid physics, combustion, science, and biology, unaware that their vehicle had been fatally compromised from the moment they reached orbit. The mission was described in daily status reports as proceeding smoothly. The crew filed no anomaly reports. On February the 1st, they were preparing for a landing that had already been fully briefed and cleared. Within days of the launch engineers at Boeing and at NASA's engineering division had raised concerns formally about the foam strike. A group of engineers requested that the Department of Defense use its military surveillance satellites to image Columbia's wing in orbit, a request that had been made and fulfilled during Columbia's very first flight in 1981. The request was routed through the Mission Evaluation Room, where Linda Ham, the mission management team chair, was told that the request had been made informally and was not being formally pursued. She was not told that multiple engineers had in fact formally requested the imagery. The request was canceled. Program managers concluded that even if the foam had caused significant damage, there was nothing that could be done about it in orbit, and that it was therefore not worth investigating. This conclusion was never formally documented as a safety decision. It was communicated informally in emails and hallway conversations, which meant it was never subjected to the kind of formal review that a documented risk acceptance would have required. The Columbia Accident Investigation Board later described this as a critical structural failure of the safety process. Decisions that should have been recorded and reviewed were instead made invisibly, leaving no paper trail that might have prompted a challenge. This conclusion, later examined in detail by the Columbia Accident Investigation Board, was factually wrong. Rescue options did exist, including an emergency mission by Shuttle Atlantis, which was being prepared for its own launch in March, and an extended mission aboard Columbia while a rescue was attempted. These options were never evaluated because the people who would have authorized their evaluation had already decided the foam strike was not a problem worth escalating. On February the 1st, 2003, Columbia began re-entry over the Pacific Ocean at 8:15 in the morning. At 8:52 a.m., sensors in the left landing gear bay began recording temperature readings outside the normal range. Over the next 7 minutes, sensors throughout the left wing failed in a progression that matched exactly what engineers later confirmed was the advance of superheated plasma through the breach in the wing's leading edge. At 8:59 and 32 seconds, Columbia's last telemetry was received. It was traveling at Mach 18.3 at 2MC of 135 feet above the Texas coastline. The vehicle broke apart over the states of Texas and Louisiana, scattering debris across an area of more than 2,000 square miles. Search teams involving more than 25,000 people, including NASA personnel, contractors, and volunteers from state and federal agencies, recovered approximately 84,000 pieces of wreckage over the following weeks, representing roughly 38% of the orbiter's total mass. Crew remains were recovered from sites across multiple counties. Some pieces of Columbia were still being found years later by hikers in the forests of East Texas. All 7 astronauts were killed. The Columbia Accident Investigation Board, which published its report in August 2003, reached conclusions that were deliberately framed as a direct response to the Rogers Commission report from 1986. The board stated explicitly that NASA had failed to learn the organizational lessons of Challenger. It identified what it called the broken safety culture at NASA, in which the foam debris problem had been normalized over years of shuttle operations in exactly the same way that O-ring erosion had been normalized in the years before Challenger. Each flight that survived without catastrophe was taken as evidence that the known problem was acceptable rather than evidence that the problem was accumulating risk. The board found that dissenting engineers had been marginalized, that the decision-making structure gave program managers authority to override safety concerns without formal documentation, and that the culture placed so much institutional weight on schedule and cost that safety engineering had effectively been repositioned as a support function for operations rather than as a constraint on them. A recovered voice recorder from the crew compartment debris later confirmed that the crew had been fully engaged in normal re-entry procedures until seconds before the vehicle became uncontrollable, meaning they had no warning of what was actually happening and no opportunity to respond, even if they had. The shuttle program was grounded for 29 months following Columbia. It resumed in 2005 and flew 22 more missions before the final shuttle landing in July 2011, when Atlantis returned from STS-135 and the orbiter fleet was retired permanently. Between the two disasters, the shuttle program lost 14 crew members in flight across 135 total missions, giving it a crew fatality rate of approximately 1 mission. in 10 resulting in total crew loss, a figure that is rarely stated plainly in official communications about the program, but that was known to NASA leadership throughout its operational life. The Columbia Accident Investigation Board noted in its report that this risk level was roughly consistent with the risk estimates that had been made internally before the program's first flight in 1981, estimates that were known to administrators and that did not prevent the program from proceeding on the grounds that the knowledge and experience gained would justify the risk. Whether they were right is a question that was not resolved when Atlantis landed for the last time, and that has not been resolved since. What is unambiguous is what the two investigations found, that in both cases, the specific technical failures that killed 14 people had been identified in advance, raised through internal channels, documented in writing, and overruled by managers whose authority to overrule them was never questioned until after the funerals were over. The engineers who raised the warnings before Challenger were right. The engineers who requested satellite imagery before Columbia were right. In both cases, they were told they were wrong by people who had the organizational power to say so. And in both cases, the 14 people who had nothing to do with that argument paid for the decision. If you enjoyed this video, subscribe for similar ones and feel free to drop suggestions for the next video in the comments below.